of decrease happened in the automobile industry around the globe. This is what Michelin and Korea Hanguk Tire shared. The market reduced down to 35%. Over 40% of a sales decrease. I'm not bragging. I just want to have something in common with you, and this is what the difficulties we had. And some reports never mention about this difficulties in the past, and we kept thinking of what we should do. Maybe we need some robot that can have some consideration for us. Due to COVID-19, our sales increased to 30% in April, and in logistics we all had a concern, and this is our conclusion. There's a fluctuation that became intensified. I didn't place the number on the screen because the number is astonishing. Lack of inventory, because on purpose they had to shut their factory for 4 or 5 days. Some areas suffer from lack of inventory, and there's a term called demurrage detention if you are in the logistics. US is the biggest market, and once you export the tire, we had a big burden even keeping our tire after shipping to the US, and we are still under big burden to all manufacturing lines, and there's a severe imbalance between supply and demands, and we started to see some issues, and I will talk about it later on. But I participated in some committee of the Gyeonggi robot industry, and I asked a question. Some robot-related policies are very confusing in the market because it tells the two different stories. First, job security. Government provides some subsidy if you have job security at your company, but at the same time, robot industries are backed by the government. I will show you some photos and videos on site, but I'm not sure, but I wanted to be honest. So some sites were extremely against the idea of the introduction of the robot because they're afraid of being replaced by robots. Because ROI started to be the topic after some robots onto the manufacturing sites. In order to resolve the human resources issue, we started to prepare some policy regarding robot. And some tire companies already had this concern in the past, but still are concerning what kind of areas we can utilize these robots in our industry. After making tire, we have lots of SKU like Sonata, Grandeur, and other models of the car vary depending on the sales market. So for example, they have over 10 types of the tires, and here we have some robotization. Maybe I should skip the video because our screen doesn't have quality. To store some goods, we had some process adopt robotization, and we are concerned. The most effective fields were found. CDC, Central Distribution Center. Just simply imagine a RDC. It's called Regional Distribution Center. You can imagine a house. In a factory, you put a sticker to show the information of the market information and specification of the tires, and about 1% of the entire workforce place the label on the tire. And for this work, we really robotization helped. Second, tire is manufactured from factory, and one of the most interesting areas for me was this. There are a lot of robot implemented businesses. For example, a company called H, and then to deploy some new models of tire, then what will happen? Some people understood what I'm talking about. With existing technology, we couldn't problem. Maybe some of you are interested in the application and implementation of a robot in your manufacturing lines. The riskiest area is here in terms of logistics. There are some companies like Twinny and DH. They have some robot cases. Yes, there are big opportunities for market. Have some issues of delivery men and their boxes because their main problem is loading and unloading due to size of boxes, different types of boxes. This is a huge market, and I'm sorry for this because it's a huge market, but we have solutions yet. We are dealing with a large volume of go, and we could implement a robot technology here, which still has a long way to go. But first, I would like to show you the case of labeling robot. By utilizing AGV at night, both in Korea and international, we only operate these warehouse at night, very late at night. Then we have a limited capacity, which we want to expand more. So with a fewer workforce working here, we want to improve this process, but still we haven't found a good solution. But this is our reality, and that is why I briefly mentioned. After picking AGV with autonomous driving works and functions the same as the previous process, but there's a limitation of a size and types of the cargo. You just saw, let's say, there's a width like this, but some AGV cannot pass by. Most of them has a weight limitation up to 100 kilograms. There are some tires for regular cars, but for other tires are for big trucks. Some trucks' tires can in up to 80 kilograms, but some robots had the issue of the weight loading. So some people suggested to make the robot bigger. So maybe we need a bulky robot for heavier loading. Under development right now, we have a lot of small robots in the market, while we still need a lot of bulky and larger robot, because the market is there, and I'm not sure how many people did in creating these type of tires. Also a contribution to of the robot industry. So as mentioned, manufacturing has inspired by COVID-19, we started to think of what type of can contribute to our industry, and we realized and we started to draw an ideal model of a robot. Selection, focus, and because we are not robot manufacturers, we just kept contacting to partners, and we ended up having a robot, so the labeling robot. Of course, the partner has the ability of creating a robot. In collaboration with this partner, we were able to create this robot. Another goal was there. We have the same products, but depending on the market that the products go, we still have different labels. So let's say you sell this product in America, Asia, or Europe. In the tire industry, the label can indicate the acceleration, the weight, loading, performance. These are the label, but depending on the countries of the market, it all is. So it's not really efficient to have one doing the same job. So in order to use a robot to our process, first of all, we to standardize our robot processes. Say you have people with 1 year career, 10-year experience, and they all have a different background, dealing with different products. So we need to standardize the operation. That's how we start this labeling robot. There was a recently established in the US, and where we started to have this robot. Let me explain. Each time in the middle has the unique bar information. And first you scan the barcode. That will tell you when it was manufactured and confirm the basic information. Also realize what kind of market this tire will go. And then you move to the next processes. So this process used to be done manually. In the US, this is pretty modernized and automated. However, for the specific process, for some reason, this is completely manual. This is a picture of before and after installing labeling robot. I'm sorry, the resolution. After a series of tests, we have some issues which is still under treating. Let me show you the video.
좀 현장 이해해 주세요.
Sorry, the video is noisy because he's on site.
죄송해요.
Sorry, the video is playing. Here you go. Thank you for letting me know. So this individual has a little sticker side with a unique code information, and with that the workers can proceed with their work. Once you read this information wrong, it has a big damage on this factory, and this American actually went through some lawsuit.
너무 단순하죠.
This is very simple. It is very difficult, such a simple robot, which I imagine. If you have realized robot in process, you do what 20 does. How is it possible you can realize the robot dealing with the elevator that is not a bulky robot? There's still some errors to recognize and scan some box, and just to reduce the error rate, we still went through the manual process to see if the robot placed the label neat or the right information was there. Well, to be honest, the accuracy is 88%. This 2% may not be significant to you, but let's say if you produce 15,000 units of tire, means 3,000. Then for 1 year, you can have 100,000 tires with defect, and some people inside the industry can use these tires. So it's important to moving towards 100% of accuracy, but it's not easy. We kept having our remote conference with our partners in the US. You can see the pictures clearly, but for our troubleshooting, we robots to the site. They attach and detach these robots and doing some tests. And I mentioned about 98% of accuracy, which is not satisfactory. So we keep updating, and some troubles we found are like simple attachment of the label inside the tire. When it used to be done by manual work, it was alright, but robots started to have a crooked movement to place the label. And I was wondering, why didn't we do it from the beginning? So this was rather improvement of the current problem, and we had to find the most effective material of the robot. Still, it has some curvature. Nevertheless, I'm revealing this information to you because I want to share some implication of this introduction robot. So one person used to do this work manually 10 times, and now maybe robot can do the same job 30 times, and in the course of that we still have some issues, and I just want to be honest to share with you from you. And my last page is my lesson in the course of implication, in the course of the implant of the robot. It was easy. It's not only for cost reduction, but for collaboration between human and robots. I didn't realize how many people will be in that American factory. I mentioned that they have nurses, so they were not that against the idea. While in Korea, I have some skilled workers with over 30 years of experience and they're strongly against this idea. They didn't really express their opinions publicly, but then they wanted to talk to me private, and then they said, "Why are we doing this? Are you kidding?" And all I wanted is just to solve a little problem on site. But still, I realized that I had a first-hand experience of the people's concern that the robots may replace these human work. Once again, introducing robots is not about replacing human job. And I've been telling these people at factories, and I hadn't enough time and effort to explain this. And still, they were not really cooperative to test this robot in domestic factories in Korea. And I think this is one of the biggest obstacles that you will encounter. Next was the obstacle to purchase the robot. You have to convince the management or board members. Of course, it's extremely expensive. If you think about the performance, the ROI, you can reach the ROI maybe after 10 years, and it's hard to collect the investment within a short period of time. And I kept telling my management, saying that we need to be preemptive and proactive to introduce these robots for the potential in the future, but it's still hard. And then we need a new business model to introduce more robots in more efficiently. So maybe some robot rental may be a good idea, and some sites are actually favorable for that. So AGV is mainly are leased, and maintenance is convenient if you are under lease, but robot is a different story. So maybe we have some good system of lease for robot in the industry. So far I've been talking about this robotization based on innovation in manufacturing logistics, centered around case and implication, and I've shared some obstacles and concerns. And that wraps up my presentation. If you had some questions, it's now a good time to tell me. If you have a simple question, maybe we can listen one or two questions. Good afternoon. I am from a company called Hansol, and I'm in the logistics. I also deal with weights. And you mentioned about heavy loading, and I totally agree with you that we need more robots dealing with a heavier loading. So you talked about one successful case and 3 failures. Well, not yet successful, but something ongoing looks promising. Maybe do you have some cases overseas? And is that why you implement that case? Or you just wanted to be the leader? And you also mentioned about, I want to talk to you privately later, but I just want to open my discussion now. Thank you for your question. Let me briefly answer that. We're not the first company. Yes, there was a case internationally. And after observing that case, we earned some insight, and we checked their facility, and we went through the customization. So it was more like customization based on that insight that we observed. And the first one was ongoing, and the 3 cases are not really failure, but we are still looking for the solution. So maybe I was hoping that to find some good ideas from you. So I want to give my business card to you. Okay, let me add more follow-up questions. So I guess maybe even if you did the labeling by manual work, I was just wondering why it still is an issue of curving. Because printing is the same whether you do it manually or automatically. Thank you for your question. So the labeling job was done by people, and those workers used to have some warm storage to keep the label warm before they attached, but the automatic facility of the labeling, the US has similar temperature and weather conditions as Korea, so the temperature inside the factory is getting chilly, so we had to deal with the issue of the temperature. Thank you. Thank you for your question. And we still have a panel discussion time when you can bring more questions. So after our next presentations, we can collect more questions. Let's give a big round of applause to Mr. Park Chun-sik. Thank you.
The first presentation will be given by Mr. Kwak In-bum from Polaris 3D Corporation. He's going to talk about autonomous driving technology in the retails. Hello everyone, I'm researching autonomous driving. I'm working for Polaris 3D. My name is Park In-bum. So we spun off from other company to specialize in autonomous driving technologies. We decided to found a company because all the autonomous driving technologies are many in movies, but not so many in reality. So we wanted to expand the usage and application of autonomous driving technology. So I decided to found a company. To further explain, we developed autonomous driving technologies and solution, and retail was the first area of application because it is one of the most difficult areas to embrace autonomous driving technologies. So stability and the performance of the solution is being tested in the retail field, and if it goes successful, we can use this technology to any industries we thought. To explain the background a little bit further, like you know, Amazon Robotics Tiva was the first autonomous driving robot. And if you see these images of Amazon, the robots are used at warehouses and they move autonomously. And finally, Amazon Prime Air and Scout service launched to deliver the product to each customer automatically. And Amazon Dash Cart have been implemented to automize the shops even. So this is a big picture that has been drawn by Amazon. Amazon is a warehouse company, but in case of retail companies like Walmart, which has actual physical bricks and stone stores, they are testing with their own locations. For example, Bosaba Robotics now automate in-store inventory status, and Magazino automates inventory management in warehouses. So, after all, the automation of warehouse and automation of retail are two sides of the same coin. So we thought that maybe we can start from retail so that we can automate the entire retail industry, including warehouse. My company thinks that there are 4 automation problems in reality, because autonomous driving is one core task for my company. And instead of developing the technology industry by industry, we thought that maybe we can categorize the entire industry into 4 categories so that we can have a better ideas of developing our technology. First, the basic driving functions, and the second, assistance function for cooperative works. Third, which is quite critical, safety. Machines should be machines should be safe and need to adapt to each situation, but the cost and circumstances can change how much safety is required. And the final 4th stage is collaboration. Collaboration for same objectives. For example, let's say that we have self-driving robots moving around within an indoor space, and self-driving capability can be combined with indoor driving so that the whole process can be automated. So this 4th stage technologies must be considered even if we develop the 1st stage technology. So we thought that we can apply these technologies to each industry and collect all the troubles we experienced so that they can feed back into the existing system to produce upgraded version of it. So that was quite a big picture I introduced. And next part is about actual retail scenarios we applied for the retail. This is much smaller topic. For example, Bossa Nova Robotics made a robot that automatically study the in-store inventories, and we did the same from last year. The stock management, inventory management. If you go to store, there are workers working around to check the inventory. If it is empty, they go to the warehouse and bring the bulk of the product and put back into the shelves. But robots can go around and give an alert to each places regarding the state of the inventory so that the workers understand how much product should be refilled for each space. That should reduce the burden for workers. So as such, the robots can look around and see the inventory status. That is the stage 1 technology we invented. If it goes successfully, next is the actual automated management of inventory. For example, on the screen, you can check the entire inventory and you know how much stocks should be refilled. And if this data can be transmitted to robots, the whole system can be automated. So SSR, or self-scanning robot, was developed that can scan the inventory of the shelves. Of course, it was not developed by our company, helped by our company. And you can break this technology into 3 parts. First, scanning and detection of vacancy. Second, vehicle, the moving part. Third, autonomous navigating part. The green marked areas were the technologies developed by my company. Let me get into more details. So, autonomous driving robots, of course, if you experience the overseas product, it's quite expensive, and you might think that why it should be that expensive. Like previous speaker, Mr. Park said, autonomous driving vehicle which can endure heavy loads do not exist, he said. Actually, there are many companies who can produce such products because technology itself has been matured. However, autonomous driving plus heavy loading is difficult. So you can separate this problem into 2 parts: self-driving, heavy loading and unloading. And if you can reduce the cost required for the self-driving, you can also optimize the cost for each application, we presumed. In case of our solution, on the right top side, it is called Polaris ANS. This is a self-driving system. So we developed this ANS solution and have applied it for multiple devices to produce the same outcome. Depending on the perfection of the moving body, the performance varies, of course. So we worked with a ClearPath, Lobonic, and AgileX, and we applied this technology to many open platforms, and the number of applications has increased very rapidly. And if we apply this technology to heavy load lifters, that would be